So on your performance final, you're going to be given 3 questions. Okay, you're going to answer 2 out of the 3 questions, but you're going to answer the unit. Okay, so there's 3 units, and here are the different types. You got complex numbers, synthetic and long division, and zeros and polynomials. Okay, you have to complete 2 out of the 3. So you could do the first 2, that's totally fine. You can do the last 2, that's fine, or you could do 1 and then 3. That's fine. Okay, as long as you answer them fully. If you want to answer all 3 of them, I'm going to take the best 2 out of the 3 to grade. Okay, so if you do all 3, I'll grade them all, and then I'll say, okay, they did well on 1 and 2 or 2 and 3. Okay, whatever it may be. So let's go through the types of questions that you're going to see. They are going to be very similar. On your performance final, you must show your work. You have to show your work. Explanations are also necessary. So I'm going to show you how to do the problem, but tomorrow or Wednesday and Thursday, you'll actually explain it. Okay, so, all right, on this first one, it's adding complex numbers. Okay, so what you're going to do when you add complex numbers is you're going to combine your like terms. Okay, so we got 4 and 6 that we can combine together. What is that going to give me? 10. And then 2i plus negative 8i. So 2 minus 8 is going to give us negative 6i. And that's it. What you would tell me about this is you are going to combine real and then combine imaginary terms. Okay, and that's what you would tell me on number 1. Are there any questions on that? Okay, fantastic. Okay, so now the next one's subtracting. Okay, so we see there's a negative right here. We're going to distribute this guy, and that's going to give us 5 plus 10i minus 3 plus 4i. And then we're going to do this exact same thing that we did in number 1. We're going to combine our like terms. So we're going to have real, and that's going to give us, all right, that's going to give us 2. And then we're going to take 10i plus 4i, and that's going to give us 14i. And that's it. Again, when you explain this, you're going to say, hey, I distributed, and then I combined my real and combined my imaginary. Okay, number 3, we're multiplying complex numbers. All right, so we got 4 plus 2i times 3 minus 7i. Okay, you can distribute or you can use the box. I personally am going to distribute. So I'm going to do 4 times 3. What is that going to give me? 12. 4 times negative 7i. That's going to give me negative 28i. 2i times 3, which is going to give me 6i. And 2i times negative 7, which is going to give me negative 14i squared. Okay, so now we're going to combine our like terms. So our like terms are going to be anything that has an I to the first power. So when we combine those, we're going to get 12. Negative 28 plus 6 is negative 22i. And instead of rewriting this I squared, we're going to write a negative 1. Okay, so we're going to say negative 14 times negative 1. Well, we know that a negative times a negative gives us a positive, right? So that's going to make this plus 14. And now I can combine my like terms. Okay, so 12 plus 14 would give me 26. And we got that minus 22i. Biggest thing on this one is remembering that I squared equals negative 1. Okay. Now, again, if you wanted to do it the box way, that's totally fine. Okay, you would get the same results, and I'm going to do that one pretty quickly. And you would get the exact same thing. Okay, it just kind of depends on how you want to set it up. Again, on your performance final, you are going to tell me how you did this. Like, write it out in words. It doesn't have to be super long, but just, this is how I solved this problem. Now, on number 4, it says knowing what a complex number is. Okay, so remember, a complex number is going to be that a plus or minus the bi. A is going to be a real number, and BI is going to be the imaginary part. So all you're going to do is you're going to write this out, and you're going to tell me that a complex number is a real plus or minus an imaginary term. Does that make sense?
Keep that up there.
Yeah. I'm gonna hit pause. So now we're gonna multiply. Now we're gonna multiply polynomials. Now you can do this the box way, or you can do this the distributive way. I'm gonna do it with the box just to show you a different way. Okay, so on number 1, we're gonna do the box. Simultaneous. Okay. So we're gonna put 5x minus 6 on the side, and we're gonna have 25x squared plus 30x plus 36 up along the top. Okay, so we're gonna multiply the sides of these. Okay, so 25 times 5 is gonna give us 125. X squared times x is going to give us x to the third. Yeah. 25 times negative 6 is going to give us negative 150 x squared. 30x times 50x is going to give us 150x squared. 30 times negative 6 is going to give us negative 180x. 36 times 5 is going to give us 180x. And 36 times negative 6 is going to give us 36 times negative 6, negative 216. So now we're going to take everything that's inside the box, and we're going to combine our like terms. Okay, so that's going to give us 125x to the third plus 150x squared minus 150x squared plus 180x minus 180x minus 216. When we combine our like terms on this, these are all going to cancel, and we're left with 125x to the third minus 216. Okay, again, you're going to write me like a cute little paragraph over here, and you're going to tell me exactly how you solve that out. Okay, okay. Number 2, factoring quadratic. So we got this 5x squared plus 90x plus 400. Now, if there is a greatest common factor that you can take out, so for instance, some type of number, or if they all have x's, something like that, go ahead and do that. You're going to take all of this, and they're all divisible by 5. So when I take 5x squared and divide it by 5, that's going to give me x squared. When I take 90 and divide it by 5, I'm going to get 18x. And when I take 400 and divide it by 5, that's going to give me 80. Okay. So far, what I've done is I've divided by the greatest common factor. Okay. That's all I've done so far. Now, I'm going to factor our normal way, you know, the big X, the whole thing. So I'm going to say A times C gives me 80 and B is 18. So what two numbers can I multiply together to give me 80, but I add together to get me 18? And an 8, right? Okay, so now I can rewrite this in factored form. I can write this out as x plus 10 times x plus 8. You remember that 5 that we divided by in the beginning? We're going to put that out front. And this is our factored form. Again, you're going to write me like a little thing that says, this is how you solve this. Okay? Okay, so on number 3, it says graphing these polynomials. All right, so what you're going to do is you're going to take each one of these, set it equal to 0, and solve, okay? What you're really going to end up doing is just kind of switching the sign. So that's going to give me x equals -3, x equals -1, and x equals +3. How many solutions do we have? We got 3. Now, in the instructions, it says to graph the polynomial. Okay, so we're going to make a little XY table. I'm sorry, XY graph. And we're going to plot the points -3, -1, and 3. So -3, -1, and 3. All right. Now, what degree polynomial is this? Well, let's look at our exponent. We've got 1, 2, and 1. If we add those together, that's going to give me a 4th degree polynomial. And that means that since all 3 of these x's, if we multiplied them out, that would give us a positive x to the 4th. Okay, so that means that our end behavior is going to be facing upwards. Okay, so I'm going to start my graph up here, and it's going to end up here as well. Now you got to remember your cross, wiggle, and bounce. Remember, cross is at when the exponent is 1, bounce is when exponent is 2, and a wiggle is when the exponent is 3 or more. Okay, so at x equals -3, we're going to have a cross. So we're just going to cross the x-axis. At x equals -1, we're going to have a bounce because the exponent is 2. So that means that we're going to go up, touch, and then come back down. And then at x equals 3, we're going to have a cross. So notice how we used our exponents in understanding what multiplicity is in order to graph it and knowing our end behavior. On number 4, it says knowing what multiplicity is. Okay, so multiplicity, this is where you're going to describe what cross, bounce, and wiggle are. Okay, and I would say that it relates to the exponents. Okay, and you're going to probably talk about cross, bounce, wiggle. So this is talking about how we graph, and it's the exponents of the factors which affect the number of zeros for a polynomial. Okay, now you don't have to write this verbatim, but you want something about this. You'll get points for this. You'll get points about talking about the exponent. Okay, I'll give you a second to finish. Ready? So right here, we got synthetic division. All right, we're going to change the sign. Okay, we're going to list out our coefficients. So 2, -5, 4, 8, and 10. Remember, if there's any term missing, we're going to have a 0 for that holder place. Like if x was missing, we would have a 0 in for that. But obviously, we have all of our numbers, so we're good. All right, we're going to bring down the first term. Multiply, add, multiply, add, multiply, add, multiply, add. Okay. Now it asks basically what is the polynomial after the fact. So we're going to drop it down one exponent, and that's going to give us a 2x to the 3rd minus 1x squared plus 2x plus 12 plus this guy's always going to be a remainder, whatever's on the right-hand side. So we're going to divide it by whatever we're dividing by up here. Okay. We are going to divide. We got 36x to the 3rd plus 12x squared plus 24x plus 6. And we're going to divide it by 6x squared plus 3x. Now you've got to do this long division because the exponent is greater than 1 and the coefficient is greater than 1. So what times 6x squared will give you 36x to the 3rd, and that's going to be 6x. 6x times everything on the outside is going to give us 36x to the third plus 18x squared. We're going to change the sign, draw our line. This will end up canceling. 12 minus 18 is negative 6x squared. We'll bring down the next term. And again, our goal is to find what the remainder is. Okay, so what times 6x squared would give us negative 6x squared? And that's going to be negative 1. Negative 1 times everything on the outside will give us negative 6x squared minus 3x. We're going to change our sign, draw our line. We're going to subtract. These will cancel. 24 minus negative 3 is going to give us 27x. And we're going to bring down the next term. Notice how we can't repeat this process. So this is part of our remainder. So our remainder is 27x plus 6. All right, so on the last one, okay, you could do synthetic division, and they don't want anything with the remainder. They want everything else. So we're going to change the sign, list out all of our coefficients, bring down our first term, multiply, add, multiply, add, and multiply. This number is huge. And then add. Okay, so they want everything except the remainder. So that's going to give us 9x squared plus 23x plus 61. So they want this as your answer, not including the remainder. Okay, that's what they asked for. Nothing with the remainder, just this stuff. Okay,